1/3 for the nut position, approximately there. I'll take the plate out and overlay it. The dashed lines are for bends, and the angle of the bends will be what it needs to be. I don't know what it is, but I'll just fit them up and bend them to the shape I want. This one here is just that will be a 90-degree bend to whatever angle that plate is. It will then be a 90-degree bend. That is just to strengthen up, excuse me, that is just to strengthen up this plate. And then of course, this gets drilled and drilled, and a spacer put in between to get that body just on the plate, or just off, but not, definitely not causing the, spaced high enough away so it doesn't pull on that. So it just needs to be slightly off the plate. Alright, leave that with me. Well, this is the plate for this way. The nut for the axis screw was mounted underneath, and that was mounted to the saddle. Yeah, that way. So I've transferred the hole positions to my cardboard, and I'm ready to go and cut this out. Let's go and do that. Okay, I've already traced out the plate. By the way, if you haven't got one of these machines, you should get one. These hand shears are marvellous. I've had this for 35 years or so. What I'm cutting here is a 2mm thick yeah, 2mm sheet. Eats it. This thing really eats. There's no problems cutting it. I've tried 3mm. That's getting it. Yeah, you've got to work hard, and you've got to bolt it down. I've out in the other part of the garage, I've got some dyno bolts or loxons in the floor, that if I'm cutting big sheet, I'll quite often use that. Bolt this down to the floor. But it's a very handy machine to have in the shop. It's a little bit heavy, but you can't do this with a pair of hand snips. Okay, got you on the other side. You won't see the back of me so much. Yes, I understand you're getting a lot of reflection, but I too do have to see. So that's the tightening the nut for the X-axis. It's bolted to the saddle. It's nice and firm, and this will be now mounted like so. Let's see, might be a bit easier for you to see now. Now, if everything worked out, this is a 8-inch or 200mm vernier. The table moves about 6.5 inches, 160mm. So I'll take it right until it hits the handle, which means the carriage can't travel any further. And we should have, there we go, that's mounted there. I can easily mount this. I'll mount the other end to a bracket off. That'll be mounted on the bracket for the Z-axis. So yes, that will work. Now to mount it, and then I can then work on mounting the other half of the vernier. I cut off the leg on this bracket and I made another one, bolted that on. It looks quite good actually. What I'm trying, excuse me, what I'm trying to achieve is clearance for the sliding bar of the vernier caliper. Clearance with the screw support, which travels above it once the work table's screwed all the way in. And I have been able to achieve that. This is just a temporary two washers, a temporary spacer. I will make a better looking one later. in the process of doing this change, I broke off the handle to my homemade or shop-made tap wrench from 1972, my first year of apprenticeship. First 3 months we spent in a workshop hand filing and doing a little bit of lathe work, and that was one of the projects on the lathe work. Never used it much until I started this job actually. I've done a lot of tapping, most of the tapping, a good majority of the tapping I should say. On this milling machine I've done with that little handle. Obviously that is a weak point, being a quarter 20 thread. Is it a quarter? Not even that, 3/16 I think. No, it's not a quarter. It's only 4 and a bit mil. So it's probably 3/16. Let's have a look. 16ths. Yep, 3/16. Look at that. It's small, isn't it? I remember when I made this, I was supposed to use a 2BA thread. I didn't understand what BA threads were in those days. I hadn't heard of them actually. I have heard of them these days. I still don't know BA threads. I don't have any taps. Anyhow, I made this and used the 3/16 coarse thread. Finished it all up, went back, presented it to the instructor, and he said, top marks for that. It was a lot shinier 40 odd years ago. He says, well, you lose a few points, 2 points for the wrong thread. So what do you mean the wrong thread? He said, I told you to go and get the 2BA taps. I think it was 2BA. Like I said, I don't know BA. Anyhow, I got, I should have got full marks for that, except for the wrong threads. And here we are 40 odd years later, I've broken it, so I might make it with, don't know if I have a tap for that. Yeah, anyhow, I haven't got a knurl for my lathe, so I can't do the knurling. I must buy a knurler. That's another thing that costs money. Anyhow, this is now mounted up. Moves nicely. I don't know if you can see that, but there's now clearance with this. So I'm now off to working on the y-axis, and I'll get into next. I'll get into where I can't mount it, then try and work out where I can. I think I've got it, but it's not ideal, but it's what I think I can do. Anyhow, that'll be coming up next, fitting the y-axis. Catch you then. A small interruption to your viewing pleasure. I'm currently, what am I currently doing? Working on fitting DROs to the milling machine, just cheap DROs, nothing expensive, cheap. The thing was made of Coke cans, for crying out loud. Yes, but I was doing, turning up an arbor for the mill to run a 7/8 cutter, and anyhow the lathe stopped. I'm not plugged in. The switch wasn't holding in, and I thought, annoying. So I pulled the lathe over here to easier to work on. I've taken the cover off, and what I noticed was two things. There's a large resistor in here, is that one, and it's a little bit toasty, but it still reads it's 13.7 kilothousand ohms, k ohms, yep, 13.7 k. So that's still working. I've got this second board as a backup, maybe if things work, and I know some parts do not work because I'll tell you about that. But I did notice the switch on the top there had melted at one stage. I don't know if you can see that, can you? Try that. There's a spot there that you can see, and then the tang itself. Where is it? That one. That way. The tang itself is bent. So the switch. So I replaced. Well, before I replaced the switch, I remember, I knew I had this board here. I got it off the son-in-law. Son-in-law said, I don't know if it works or not. Well, it doesn't work. I don't know if it was the control board giving the problem or whether the motor had stopped working. He had bypassed the fuse, and still things weren't working. He didn't know, I didn't know, and I thought, well, it looks awfully clean in there. Very similar, same manufacturer, but it's a later model. So there are some minor differences. But the switch was the same, the drum switch is the same, and the potentiometer looks like it's the same. So there's some parts here, components here I can use. I thought, well, hang on, I'll just plug the board in, this one, this spare, and I'll use that and keep mine as a spare, minus its magnetic switch. So I wired it up carefully, made sure all the wires were going to where they're supposed to go. There's not many, just the two power leads and then the motor, the black and white motor leads, then the two power leads onto there. And I made sure that the wiring inside here was roughly going to things the same as, in this one, the same as on mine. And it looked pretty good. Turned it on. Unfortunately, I should have had the camera going. It would have been, it was exciting. It would have been very interesting for you. There was a horrible large flash from the bottom corner here that was sitting that way. Horrible large flash, a fairly loud bang, and then fire, yellow flames of fire. So I quickly turned the thing off, and I don't know what's happened. I don't know much about electronics. I just poke around and see things. Where are we? There we go. As you can see, all the black in here. So these switching diodes or whatever they are, SCRs or something, I don't know. One of those is totally fried. The board's a little bit fried. So, I'll keep it. I'll keep it for the drum switch on the potentiometer and that resistor. That's how I know, and that resistor was 13.7 K, and I know it's still okay. So I'll keep it for those parts. And a fuse housing here, which I probably won't never use. Anyhow, I put the spare switch into this, and we're back in business. Can I safely turn it on? Let's see. That's okay. That's not going to foul anything. Don't want to stick my finger in there. But move some tools out of the way, and let's have a look. No smoke. That's good to know. It's off. It clicks and holds in there, and I haven't got drive. So everything works. I'm back in business. Yes, I'm unplugged now. Excuse me. While I've got it out, this is not something I can understand. I love the DC control, the variable control. The DC motor works really well. You know, it's a beautiful little lathe. It has a high-low gearbox in it. I've fitted metal gears. I'm really happy with it. But when it stopped, like I said, I'm not familiar with electrics. I can change a power point. I can understand that part. So, basic electrics, yes, I'm familiar with. But when it comes to electronics, I know a little bit. Probably a little bit too much for my own good. But I do get confused with it. This board isn't too bad. It's only got small components on it, but the replacement board, this one here, which now is fried, there is a fair amount of surface mount technology in there with resistors and transistors. Yeah, there's a fair amount of surface mount technology in it, and it's like I said, I can't test it. I could repair this one if I knew what was wrong, but I'm not up to speed. So anyhow, while I've got it out, I'm going to take some measurements, do some drawings up for in case one day when either this motor stops or this board packs it in, I will change it out to a simple motor up here, belts, pulleys, drive into the, I'll put a drive shaft in place of the motor, and yeah, just a normal 240 volt electric motor, like I've got on the milling machine. Easy to understand, easy to control. It has an on-off switch, that's it. Something goes wrong, I can either see it, smell it, or toss it out and replace it. This board is, if I can get one, they're very hard to find. If I can get one, it's about $150 plus freight. If that's got to come from America, there's another 40 bucks, 50 bucks, yeah. So I'm looking at $200 minimum. Some of these boards were 190 something American, but I don't think that was mine. I think the one I wanted was about 150, about 120. So no, that's nearly 200 Australian dollars. I'm not going to spend that kind of money out to the tip. But at the present moment, it's working. It's working well. Goes back together. Stays standard. But while I've got it off the bench over there, I've got some room. I'll take some measurements and do some drawings up. Do a bit of a CAD, and get it ready for when this packs it in. I can make or already have made the modification to turn this into a straight pulley and pulley and V-belt drive. Alright, back to normal programming. See you later. I'm making a shoulder bolt for the mounting the sensor, or the black part, the box of the Y slide of the DRO. I need a shoulder here of 3mm of the thickness of this plate. That feels good.